Guys, welcome to our video of today. So this one we are going to focus on example 3. Before we start, you're going to need to use a calculator. Okay, so I currently have an older version of 83, TI 83. If you have a Casio, great. If you don't, you can actually download, look at that, those are my triplets, download an app, but my app connection is not working. Okay, so if your app is working, go ahead and download an app called Desmos. Okay. Desmos is a graphing app that will do a lot of the things we want to do. Okay, not all the things, but enough to go by at home. Now, if you have an Android phone, there's a free TI-83 app that we can download on it. Okay, on your Android phone, and it looks exactly like this, and it will do everything that the TI does. So you come and talk to me if you have an Android phone. All right. So Android phone, you can get a free TI on your phone if you can download. But right now, download Desmos. Pause for a second. Download Desmos so you can get working. All right. So I have a calculator. Here we go. Example 3, the average cost, which is denoted as C with the bar on the top, which I'm going to zoom. Okay. C with the bar on the top, of manufacturing X computers per day is given by the function average cost of input X equals 0.56X squared minus 34.39X plus 1212, so 1212.57 plus 20,000 divided by X. Determine the average cost of manufacturing 30 computers in a day. So I'm looking for, hey, what's the cost of producing 30 on average computers per day? So with this, we have seen this already where we're going to put this 30 in as your input. So this right here is your input. Okay, your X is your input. So average cost of 30 computers per day is 0.56 times 30 square minus 34.39. Oops, that doesn't look very clear or neat. So let me use my whiteout and white it out. So that looks like, there you go. So minus 34.39 times X, and X is 30 computers, plus 1,212.57. I'm running out of space. I'm just going to go down here and do the 20,000 divided by X. So plus 20,000 divided by 30 computers. Okay. Now most of us, if you don't put this in parentheses on your calculator, you're going to get the wrong answer. So make sure you go and put it correctly. I understand that many of you are probably not going to use a calculator and follow along. If I were you, I would. Okay. Pause it. Punch this in on your calculator. Then unpause to see if your answer and my answers are matching up. Okay, so here we go. 0.56, open parentheses, 30, close square. Then minus 34.39, open parentheses, 30, close, plus 12.57, plus, open parentheses, 20,000 divided by 30, close that. So I have this number. And because it is a question about costs, I did not tell you how to round because it's dealing with money, so you know you need to round to 2 decimal places, okay? So the average cost of producing 30 computers in one day is, and is $1,351. 1,000 with money, okay? So $1,351 point, and I'm rounding this to 54 cents. The reason this is 4 because this digit right here is 5 or more, so it turns this number to 4, so 54 cents. Okay. All right, let's make this line to organize ourselves. Okay. B, determine the average cost of manufacturing 40 computers in a day. Right? Why don't you get a head start on computing 40 and then, or just hit pause, and then you can come back and double check it. Okay? So I'm going to work it out as C of 40 equals 0.56 times 40 square. I'm going to write smaller because I want to fit it all in. Minus 34.39 times 40 plus 12.57 plus 20,000 divided by 40. Okay. And I'm going to write this in parentheses because I know I want my calculator to have it as parentheses. So the average cost of producing 40 computers in one day is, all right. So now my job to punch this in. 0.56, open parentheses, 40 square minus 34.39 times 40 plus 12.57 plus, open parentheses, 20,000 divided by 40, close it, enter. Okay, so it looks like $1,232.97. $1,232.97. Okay. So those two are the answer to A and B. It looks like the more computers I produce in one day, or this company is producing in one day, is the cheaper it is on average. Okay, so right now, I want you to take a second or two or a minute or two and do C on your own. So if you are listening, you are to do C on your own. And if you're not listening and you're not doing C, I cannot give you a stamp. So please do C on your own. Okay. As you guys are working out C, can I give you a joke? Okay. What do you call a fairy who does not take a bath? What do you call a fairy who doesn't take a bath at all? Stinkerbell. You get it? Instead of Tinkerbell, it's Stinkerbell. Well, there's my joke of the day. Alright, so now you should be getting 50 computers in a day. And I'm going to check that when I stamp your assignment in class. Next, part D. Graph the function C. Okay, so remember, C was denoted as the average cost, which is the same as C of x. I do have a function C of x, okay? And I only want x from 0 to 80. Now let's talk about x. What is x? What does it represent? Okay, so for this problem, x is right here, and it represents x, computers per day. Okay, how many computers we produce per day? So we're going to label that correctly on here. X is the number of computers produced or manufactured per day. Okay. So it's just not x anymore. If you're dealing with a word problem, it's no longer x. And it only wants from 0 to 80, so I'm going to label this correctly. I'm going to start at 0. I'm probably going to do it by 10. Okay, so 10, 20, 30, 40, 50, 60, 70, and then 80 right there. All right. Now, if I'm producing computers and it says, hey, label your x-axis correctly based on our word problem, then what is the y? The y is the output, and the output right now is the average cost. And no, you cannot. Okay, I'm going to repeat this. And no, you cannot. You may not just write x and y in a word problem like this. So it says graph it. So I'm going to go to, if you don't know how to graph it, I'm going to walk you through this from beginning to end. Hit y equals. I have stuff on there. Clear it out. I'm going to enter in this equation because it said graph the function c, which is the same as c of x, which is, you already have it. So you just put it in, 0.56. This is your x right here. Oops, which you can't see. This button is your x. Okay, hit x. Do not use the alphabet x, which is like alpha this. Just use this all the time. Okay, this is what I want you to use. So x, and the square button is right here. So 0.56 x squared minus, so minus 34.39 x, add 1212.57, and I want to add again, open parentheses, 20,000 divided by x, which is this button, close it. Your window, x min and x max, is going to talk about this, your input. Well, it gives you, this is your window right here. Window for x. Okay? So you should have enough information to create your own window. So the smallest value, which is x min, is 0. We're not going to produce negative computers, so that's why it makes sense to be 0. The most computer you're going to produce per day in this case is 80. So go down to x max is 80. Well, it says x scale. I mean, hey, what do you want each tick mark to be? I've decided to let each tick mark to be 10. So I'm going to go 10. Okay, x scaling, hey, each tick mark is worth 10. Now the y and stuff, you don't have to do anything right now, so I'm going to show you something. I want you, once you put in the x stuff, x min, x max, if you really wanted to, you can also put the scale for y1 as well. I normally do the y scale as 1. No big deal if you do. Okay. Now zoom, hit zoom, and go all the way down to where you see the word zoom and fit together. So zoom fit and hit enter. Okay, so zoom fit and hit enter. The zoom fit will give you a standard Y window. See this right here? Okay, so the zoom fit will give you a standard Y window. Sometimes it's too big, so hit window for me. Okay. The Y window right now starts out as a Y minimum as 1200-ish, and a maximum of 24,000. Sometimes I don't want it to be that large, so I adjust a little bit of it, okay? So Y max, I would just want it to be, let's say if this is 1,200-ish, I want it to be, how about just, let's try 10,000, okay? 10,000. And the zoom fit will give you a sort of a normal window, okay? But you have to go back and fix it and hit graph. There you go. I like this slightly better, okay? And I mean, look, I can still see, you know what, there's still too much Y, I can't see that much. You can go back to window and fix your Y again to maybe 5,000, okay? There. That looks a lot better. You have more of an output, of a defined output. Okay, perfect. So I'm going to graph this out. It tells me to do so. So how do I use the calculator to help me graph? I want you to hit second, and table. Second, table. Okay. Now currently, this is all by 1. See it right here? So this is all by 1. I don't want it by 1. It's kind of a lot of work. So go to table set. See this right here? Second table set. You're starting at 0, which is perfect, but it says a delta table. That means how much you want to be each increment by. I want each increment to be by 10 because that's what I have on my x-axis, and enter, and go back to second table. And now it's increment by 10. So if I produce 0 computer per day, I'm not going to have an average cost, okay? But if I produce 10 computers per day, I should have 2,224. So let's make this cost, I need to scale this. Let's make this cost by 500 each. Is that okay? 500, 1,000, 15, 2,000, 2,500, and 3,000. Okay. So my first, if I produce 10 computers per day, my average cost is about 2,900. So you're eyeballing this, okay? So 2,900. if I produce, can you see that? I'm trying to find a spot. There you go. If I produce, there's a glare on my screen. There you go. If I produce 20 calculators, I'm sorry, computers, my average cost is now all of a sudden 17-ish, 1748, okay? So 20, 17 is, this is 1,500, so 17 is right there. If I produce 30, it's 1351. 1351 is right there. If I produce 40, it's 1233. Okay, which is pretty close to what we did when we did it by hand. So 40, 1233. If I produce 50, 1293. So 50, I'm going back. Okay, so 12, slightly more than 40. If I produce 60, it's 1498. I'm creeping back up. So 60 is almost 1500. And I gotta go down to get the last two. Okay, 70 and 80. There you go. 70, I have 1835. So 70, which is past 15, somewhere here, it's 1835. And then last one on my window, it's just 80, is 2200, almost 23. Okay, so we're gonna go 80 computers, almost 23. So I'm gonna go over here. So those are enough dots. Okay. And I tend to miss my dots quite a bit, so what I do is I'm just gonna make it larger. Anytime you miss your dots, make it bigger, you know? Why not? Graphing by hand is never perfect, so try your best. Alright, so there's what we have for the function. And again, remember, you're doing C on your own, so make sure C is closely to this as possible, right? The output. E, last piece of the day. Which value of x minimizes the average cost? That means which value of x, okay? X means you're talking about the computers. Okay, and this is where you're going to use your graphing calculator the most. To minimize the cost, here's my graph. Okay, would you agree that the x-axis is the computers, average computers per day? The y-axis is where we're talking about the average cost. And I want the lowest average cost. Well, the lowest average cost should be somewhere down here, right? I don't know where, but I'm going to try to figure this out. So here's how you find using your graph that's already on the calculator. His second trace. I want to find the minimum. See this right here? This is number 3. So go to the minimum. Now, see this blinker? See it's blinking right here? I'm going to zoom in really quickly. Alright. Alright, check out the blinkers. It's barely blinking, but currently that's where it is. The first question, once you hit the minimum, it says left bound. Well, left bound means I'm on the left-hand side of the screen. So go to the left-hand side of the screen. Alright, so see, I moved it, this blinking piece right here to the left-hand side. I'm going to hit enter. Again, so hit enter. It's going to prompt, where is your right bound? Where's the right-hand side of the point you're trying to locate, which is the minimum point, which is, I know, somewhere down there. So I'm going to move it to the right of the screen. Keep on going. I want to go far enough to where I can see the blinking piece easily. Okay, right now it's still blinking right there, and I'm not sure that's why I want to stop, so I'm going to keep going. Alright. So I know this can't be the lowest, so I'm going to stop right there. So that's the right-hand side of the point I'm trying to locate. Remember, I'm trying to locate something down here. Hit enter. And it said, yes, with a question mark. So, yes, I do want you to guess for me, computer. Alright, so check this out. It's prompting two numbers. One is an X, and one's a Y, okay? Remember, the question says, which value of X minimizes the cost? So which one should we use to answer our question? Remember, what value of x, right? So x is going to be this one. Well, we can't produce 41.22 computers, so you're going to round it to whole computers, okay? So this is really 41 computer total. So to minimize the cost, to minimize the average cost, we need to produce about 41 computers. Okay. And I need to zoom out so you can see what I'm writing. And this is the end of our day.